Trigonometric ratios of complementary angles. In this video, we'll look at the relationship between the trigonometric ratios of angle A and its complement, which is 90 minus A. Let's start by drawing a right angled at B. So the angle at vertex B is equal to 90 degrees, which means the sum of the other two angles, angle A plus angle C, will be equal to 90 degrees. Sum of these two angles is 90 degrees, then A and C are complementary angles. A is the complement of C, C is the complement of A. So we can say angle C is equal to 90 minus angle A. From now onwards, we'll skip this angle symbol and write it for ease as C is equal to 90 minus A. Step 1, what are we going to do? We're going to be computing the trigonometric ratios, all 6 ratios for angle A. Let's start by marking the sides, what AB, BC and AC are for angle A. This is angle A. BC happens to be the opposite side to angle A. AB is the adjacent side to angle A. AC is the hypotenuse to this triangle. Let's compute all 6 trigonometric ratios starting with sine. Sine A is equal to opposite side by hypotenuse. Opposite side is BC divided by hypotenuse is equal to AC. Cos A is equal to adjacent side by hypotenuse, which is AB by AC. Tan A is equal to opposite side by adjacent side, which is BC divided by AB. And the reciprocals, cosecant A is 1 by sin A, so it's AC by BC. Secant A is equal to 1 by cos A, is equal to AC by AB. And lastly, cot A is equal to 1 by tan A, is equal to AB by BC. Here are those values in a printed form, so keep this in mind. We'll be recalling this in a couple of slides down the line to compare it with the ratios of complementary angles. Step 2, we'll compute the same 6 trigonometric ratios. This time, we'll do it for angle C. Right? So we'll mark this triangle. In angle C is this. AB happens to be the opposite side to it, BC is the adjacent side to it, and AC is the hypotenuse. Because A and C are complementary angles, we can write C to be equal to 90 minus A. So in this step, every time we write C, we'll be replacing it and writing it side by side with a 90 minus A without loss of meaning. As long as A and C are the complementary angles, whenever you write C, you can replace it with 90 minus A. Let's get started. We're going to be writing all C as 90 minus A. So sin C will be sin of 90 minus A. Cos C will be cos of 90 minus A. We mark these sides. AB is the opposite side, BC is the adjacent side, and AC is the hypotenuse. So let's repeat this exercise. Sin C is equal to opposite side by hypotenuse, which is AB by AC. Side by side, we're going to be saying the sin C is also equal to sin of 90 minus A. So I'm not going to be repeating it. As you see, you'll notice it and keep it in mind. Cos C is equal to adjacent side by hypotenuse, which is BC by AC. Tan C is equal to opposite side by adjacent side, which is AB divided by BC. Look at the reciprocals. Cosecant is 1 by sin, so it's going to be AC by AB. Secant is 1 by cos, which is AC divided by BC. And lastly, cot C is equal to 1 by tan, which is equal to BC divided by AB. Here are those 6 ratios in a printed form. The third slide, I'm going to write both these things, sin of A and what would it be when it comes to angle C. Let's look at what ratio of angle C will be the same as sin A. Start with sin A. Sin A is equal to, we'll mark these angles for a moment. Angle A, this is angle 90 minus A. For angle A, BC is the opposite side. For angle 90 minus A, BC is the adjacent side. Correspondingly, for angle A, AB is the adjacent side. And for 90 minus A, AB is the opposite side. AC is the hypotenuse, whichever is the angle that you are looking at. So sin A is equal to opposite side, which is BC divided by hypotenuse. What is BC when it comes to 90 minus A? BC happens to be the adjacent side. So we'll be saying this is adjacent side divided by hypotenuse when it comes to this angle C. What is adjacent side by hypotenuse to angle C or angle 90 minus A? Adjacent side by hypotenuse is cos. So this is equal to cos of 90 minus A. So sin A is equal to cos of 90 minus A. We'll run through the main 3 ratios in this form and then quickly summarize it for the reciprocals. Cos A, the side adjacent to angle A is equal to AB. So AB by AC is equal to cos A. What is AB to angle 90 minus A? AB happens to be the opposite side. So this is opposite side by hypotenuse when I'm looking at it from angle C or angle 90 minus A. Opposite side by hypotenuse is that ratio is sine. So sine of 90 minus A is equal to cos A. Let's look at tan A. Tan A for A, we'll be looking at opposite side divided by adjacent side, which is BC by AB. What is BC when it comes to this side 90 minus angle 90 minus A or angle C? BC is equal to the adjacent side. So it is adjacent side divided by AB is the opposite side to 90 minus A. So adjacent side by opposite side. Opposite by adjacent is tan. So adjacent by opposite is cot. So cot of 90 minus A is what it turns out to be. So sin A is equal to cos of 90 minus A. Cos A is equal to sin of 90 minus A. Tan A is equal to cot of 90 minus A. So when you're going to the reciprocals, we'll essentially have cosecant A is equal to secant of 90 minus A. Because we are taking a reciprocal for this, take a reciprocal for this. Similarly, secant A is equal to cosecant of 90 minus A. We're taking the reciprocal for this, take the reciprocal for the right hand side. And lastly, we'll have cot A, we have taken the reciprocal of this. Reciprocal of cot is equal to tan, which is equal to tan of 90 minus A. We'll summarize this entire thing in a printed form. Sin of 90 minus A is equal to cos A. Cos of 90 minus A is equal to sin A. Tan of 90 minus A is cot A. Cosecant of 90 minus A is secant A. Secant of 90 minus A is equal to cosecant A. And cot of 90 minus A is equal to tan A. This is what we call as the relation between the trigonometric ratios of complementary angles. There is angle 90 minus A and A. What is the relation? Sin becomes cos, cos becomes sin, tan becomes cot, cosecant becomes secant, secant becomes cosecant. Right? So keep this in mind. This will be very useful in solving quite a few questions. At the end of this video, we'll look at quite a few examples to get conversant with this idea.